Okay. So slope is the rate of change maybe if I could actually write it. Slope is the rate of change between any 2 points on a line. It measures the steepness of that line. Okay. So to find slope on a line, we're going to find the ratio. Now, that's a familiar word that we've used this chapter, ratio. What do you think of when you think of ratio? How do you normally write a ratio? With a hyphen? Not a hyphen. A colon, maybe. There's another way. That's one of them. That's one way to write it. It's not the most popular. Typically, when we write a ratio, we just write it as a fraction, don't we? Like 8 to 10 or something like that, right? We're just going to write it as a fraction. So when it says ratio, we're thinking fraction. And how do I write this fraction? Well, I'm going to find my slope, find the change in the y coordinate over the change in the x coordinates. The change in y we call the vertical change. That is because the y-axis is the vertical axis. You can see it on the board over there. The x-axis is the horizontal axis. So that's why we put x on top. Do you remember when we were doing unit rates, we always put y on top? This is y. No? Okay. Not even a titter. I see how it is. I can't even crack any jokes. You guys are not for it today. I see. So we want to find the vertical change over the horizontal change. That is called the rise over run. This is what I'm going to refer to when I say slope from now on. We're just going to say rise over run. Rise is the horizontal change. Run is the, I'm sorry, I said that wrong. Rise is the vertical change and run is the horizontal change. So this is how easy it is to find the rise over run. Locate 2 points on your line. Count how far up you have to travel or down you have to travel to get from one. That's called the rise. So we have to go up. In this case, we are going up 3. You can see they've already wrote 3 there. And then we're going to travel right 2. So our rise is 3 and our run's 2, and we write the fraction 3 over 2. If you can count by ones today, and you can remember which number goes on top, the rise number goes on top, then you're going to have no issue tonight with tonight's homework. Now, the slope of a line is the same between any 2 points on the line because the lines have a constant rate of change. The slope of a line is the same between any 2 points on the line because the lines have a constant rate of change. So I'm going to prove that to you here. This first example says, find the slope of each line using the 2 black points. Then find the slope using the 2 pink points. Does the slope change? Well, according to our definition, it shouldn't. So let's find the slope using the 2 black points. Can someone please tell me how far up I'd have to travel to get to this level? Ashlyn? That's right. Yep, so we're going to say 2. That's a rise of 2. How far to the right do I have to travel? 3. So I would say that my slope is 2/3. You have to put the rise number on top, which was 2. Okay, don't write it as 3/2 because that'd be run over rise. And we want to put the y on top, the y-axis number. We want to count the rise first. So 2/3. Now, if I use the 2 pink points, I should get the same thing. Now, you might be looking at that and go, how is he going to get the same thing? They're way farther apart. Yeah, our fractions can reduce. To go from one pink dot to the other pink dot, looks like I have to travel up here. 1, 2, I'll count here. 1, 2, 3, 4, 5, 6. So I'm going up 6. And then to the right, 1, 2. 1, 2, 3, 4, 5, 6, 7, 8, 9. So my slope is 6/9. Well, guess what 6/9 reduces to? 2/3. Yeah, you can reduce. What can you reduce 6 by that you can also reduce 9 by? 3. Yeah. So 6/9 is going to reduce to 2/3. So no matter which 2 points I use, I always get the same slope because it's constant. I'm always rising. You can tell right here. Rise 2, run 3. Rise, I'll put it, I guess you can't see me on the video. Rise 2, run 3. Rise 2, run 3. Rise 2, run 3. I'm always going to be rising 2 and running 3. That line is constant. If the slope changes, that means your line is starting to curve and it's no longer a line anymore. Okay, let's do the example B. Let's do the black dots first. Now, what you'll notice here is that to go from one black dot to the other black dot, if I start at the one, I always start at the point that's on the left side. Instead of rising, I'm actually going to fall. 1, 2, 3, 4, 5, 6. I'm going to fall 6. Now, the way that I'm going to represent that then is as a -6. That shouldn't surprise you, because if you look over here on the board, traveling to the left is a positive, or sorry, traveling to the right is a positive direction. So is traveling up. But traveling down or to the left are both negative directions. Don't numbers get larger as you count up and smaller as you count down? They get larger as you move to the right, but more negative as you move to the left. Okay, so as long as you can remember that. When I go to the right, is that a positive or negative direction? Positive, so I'm going to put +2. So my slope is -6/2. That's going to reduce to what? -3. You can write your slope as an integer. So even though a ratio means a fraction, you can write it as an integer. If it reduces to -3/1, which this is just a -3/1, that's the same as -3, and you can just write -3. Now, question came up in the other class period. What if instead of going down and to the right, what if I would have started at the right point and gone up and to the left? So let's do that. What if instead of always starting at the point that's on the left side, what if I started at the point that's on the right side? Well, instead of going down, I'm going to go up. How should I represent going up? Positive or negative? Positive. And that's 1, 2, 3, 4, 5, 6. That'd be +6. How should I represent going left? Negative. So then I get a ratio, instead of -6/2, it's +6/-2. But guess what? It's still the same. When we did division problems back in chapter 1, it didn't matter whether the first number was negative or the second number was negative. If there was one negative, your answer was negative. Now, what if there was 2 negatives? It would make a positive, but here I only had 1 negative. So it does not matter if it's your rise number that's negative or your run number that's negative. It will be negative if there's 1 negative. In fact, the way I write it is I'll typically put the negative in the middle of the fraction instead of up top with a number, just because it doesn't matter. It doesn't matter which one's negative. Okay, so a couple things to keep in mind. Although you can reduce your slopes, and you should never write your slope as a mixed number. For example, if your slope was 5/2, that's an improper fraction ratio, do not change it to 2.5. You can reduce it to an integer, but you can't make it 2.5. How many numbers do you see right here? 2.5. There are 3 individual numbers in that mixed number. That's too many. Okay, it is not a mixed number. So never write your slope as a mixed number. Also, never write your slope as an ordered pair. An ordered pair is another way of saying a coordinate point. So if your slope is 5/2, that does not mean it's 2.5. And that does not mean that you would write 5, 2. In fact, 5, 2 most likely is nowhere near where your line is. Okay, that's a location. Slope's not a location. Slope is a steepness represented as a fraction. Okay? So yes, I can reduce this to -3, but if this was 7/2, I'm not going to write that as 3.5. I'm just going to leave it as 7/2. Okay. All right, let's move on. Let's see how well you guys can do this on your own. Can you find the slope of example A? And if you can, see if you can do example B. I'll give you guys a minute to try that. Try to find the slope of example A and example B. Remember that if your fraction reduces, you should reduce. Just don't change it to a mixed number. You can fast forward this part of the video if you want to, or you can try it on your own and see if you can get it on your own. Is anyone willing to share what they got for example A? Branson. That is correct. Nice job. What did you say after that? You said 5/2, and then you said, but not negative, right? The reason it's not negative is because you're traveling up 5, which is a positive direction, and you're traveling right 2, which is also a positive direction. So you just write this as 5/2. This was the example I was talking about when I said that we definitely don't want to write that as 2.5, right? We just leave that as 5/2. Now, if you're trying to be a bit rebellious and saying, well, you know what if I want to start the other point? I don't want to do what Branson did. Well, you would be traveling down 5. How do I write that? -5. And you would be traveling left 2. How do I write that? And what's 2 negatives make? Yep, -5 for -2 would still reduce to 5/2. You'd still, well, reducing by taking away the negatives. 2 negatives make a positive. What about example B? Was anyone able to finish that one? Hannah. That is correct. Nice job. So when we count our rise, I'm going to use red. Red's the best color to see on these coordinate planes. When you count your rise, it's 2. And when you count your run, you should get 6. But Hannah, what did you say 2, 6 reduces to? 1/3. Nice job. Reduce your slopes. Just don't change them to a mixed number. It should always be a fraction or an integer answer. Okay, no mixed numbers. If you're wondering why when you guys did your fractions earlier in the year and I said, I'm not going to require you to change them to mixed numbers, this is why, because we don't even use mixed numbers when we're talking about slope. It's just extra work. All right, let's try example C. What's my rise going to be on example C? 5. Positive or -5? Positive because I'm going up. What's my run going to be? Also 5. So I write 5/5. What's 5/5 reduced to? Just 1. Yep. If your slope reduces, that means there were closer points you could have used. For example, 5/5 is the same as 1/1. So I could have just traveled up 1/1 and still been on my line. Up 1/1, up 1/1, up 1/1. Right? The one that Hannah did, she reduced it to 1/3. That means instead of going up 2/6, she could have gone up 1/3 and been on the line. Is that point on the line? Absolutely it is. Yeah. Why didn't they give us that one to use? Well, that's up to them, I suppose. All right. You could have used it, but here's my thought. Why be 99% sure that that point's on the line when I'm 100% sure that these points are on the line? I can reduce it really easily. I'm just going to use the points they give me. Okay. I'm going to use the points they give me. Okay, look at the last 3 problems we did. Each of the lines has a different steepness. All right, I get that. 5/2 is bigger than 1. So that line's steeper than this one is. But what do you notice about example D that the other 3 lines we've done don't have? What's different about this one? Ashlyn? Okay, so it's a little flatter. Okay, what about the direction, Hannah? Goes down. It's sloping down, right? Yeah. So if I think of my line as an escalator, and I'm always boarding my escalator from the left side, the same direction I read pages, right? If my line takes me up, it's going to be a positive sloped answer. But if my line takes me down from left to right, it's going to be negative. Well, let me prove to you that it's going to be negative. I'm going to go down So if I go down, I write that as -1. And I'm going to go to the right, 1, 2, 3, 4, 5. Because I'm traveling to the right, I'm going to write that as a positive. Well, -1/5 is -1/5. For your slope to be negative, one of those values will be negative, not both of the values. If both of the values were negative, two negatives make a positive. Yeah, so to be a negative slope, it has to have one, either the rise or the run that's going to be negative. In this case, it was the rise that was negative. But if I flip this around and go up 1, but left 5, this time it's the run that's negative. And it does not matter. Either way, I'm going to write that as -1/5. Guys, you can't screw this up. You can go whatever direction you want to go, up and to the left or down and to the right, you're still going to get -1/5. So there's no strategy that, oh, he always starts at the left dot. It doesn't matter. It doesn't matter. You have to remember two things. Well, up is positive, right's positive, left is negative, down's negative. You have to remember that. You also have to remember that the rise number goes on top, not the run number. Run goes on bottom. Rise over run, rise over run. You've already made it farther than period 1. Let's keep going. Is this slope going to be positive or negative? It is going to be negative. That's right. I'm going to travel down 1, 2, 3. So there's my negative number because I went down 3. And I'm going to travel to the right 1, 2, 3, 4, 5. What does that make my slope? -3/5. And when I write it, I typically put the negative in the middle. Although you could put the negative with the top number or the bottom number and it would still be the same. So the question comes up, what are we writing on our work papers then? Exactly this. I'm not going to make you write anything on the graph. All you have to do is be able to count. I'm just showing you how I'm counting. On your work papers, you would write down your fraction answer and that's it. If your fraction answer reduces, make sure you also reduce it on your paper. Example F. Okay, something's a bit different about example F. What's odd about this example, Hannah?
The 1-5 thing.
Mhm.
Is,
It's in a half spot, which actually is not a half spot. Because what are they counting by on the y-axis? By 2's. Yeah, so that half spot is actually just a 1 spot, right? Because it's counting by 2's each square. That means it's counting by 1. So when I count here, my rise, I want to be very careful that I'm going from 5 to 8. By the way, how far up are you traveling to go from 5 to 8? 3. I don't even need to draw the arrows, do I? I could literally just do that. And if you count 1, 2, 3. Yes, to go from 5 to 8, we're going up 3. To go from 1 to 2, we're going to go up, or we're going to go right 1. I'm going to try to erase this. So although you may not really use the numbers with the coordinates, they're there to help you check. To go from 5 to 8, that means I'm rising because you put the y on top. Rise over run. I'm rising up 3. I'm moving to the right 1. What does 3 over 1 reduce to? Just 3. Yep. So I'm just going to write 3 as my answer. In fact, big ideas I don't even think will accept 3 over 1. Make sure you're reducing it to the whole number. If it reduces to a whole number. Example G. Ooh. What am I rising? None. Okay. What's my run? 4. What's 0 over 4 reduced to? Just 0. And that makes sense. A slope of 0 is completely flat. It doesn't slope at all. What about example H? My rise is 4. My run is nothing. What's that reduced to? Nice job, Ashlyn. That reduces to undefined. Do you remember at the beginning of the year I said you cannot divide by 0? Anytime we're supposed to divide by 0, or anytime 0 is the bottom number of a fraction, I can't fit that whole word on there, so I'm gonna abbreviate. Anytime 0 is in the bottom number of a fraction, you have to write undefined. That's not a slope, that's a cliff, right? So I've got 4 types of slopes. We've already talked about positive slopes going uphill from left to right. If it takes you up a floor, it's positive. If it takes you down a couple floors, it's negative. If it's one of those people movers and it just doesn't move, take you up or down, it's 0. Think about if you were sledding on that line. How much fun would you have?
None.
0 fun, right? And what if I was sledding on this line here? How much fun would I have? I would die. Is that fun? I don't know, right? That's undefined. That's not a slope, that's a cliff. We'll talk more about this later. Real quick before you guys go. There are 2 slope homeworks, right? Both on big ideas. I told you yesterday that you'd have to do a separate paper for both. That is not true. I looked at it. I only assigned 6 questions, I think, from today's homework and like 12 from tomorrow's homework. You can put them on one paper, front and back if you want to. I would go ahead and start Tuesdays and see what you can get done. You should be able to do it, make a big dent in your homework already. Just what we learned today. See you guys later. Thanks. You too, Ashlyn.